Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to venture into Chapter 2, and we're going to start talking about algebraic expressions, and from there we're going to lead on into equations. This is, give me 1 second, please. All right, guys, so this is a very important, like every chapter, but it's very important because we're still learning the basics of what makes up algebra. And algebra is heavily involved with vocabulary, believe it or not. Because when you're reading word problems, most people do poorly because they don't know the vocabulary. So I'm going to do my best to really explain all vocabulary, and I need you guys to really learn it. So let's get right to it. First of all, quantity. And a quantity is an, okay, we'll just do that then. Okay, a mathematical quantity, sorry, I don't know what happened there, is anything that can be measured or counted, okay? Some quantities remain the same, those are called constants, and some quantities vary, those are called variables. So a quantity is anything that can be counted. For example, the number of slices in a pizza, that's a quantity. The number of shoes that you have in your closet, that's a quantity. The number of students in my room right now, that's a quantity. Yes, sir. If you, that, correct, 5 slices of pizza is a quantity. Very good, my man. So a quantity, the number of classes that you have, that's a quantity. Anything that can be counted or measured, my brothers, okay? Now, let's see if my animation works with this. I'm not too impressed with this right now. I don't know why it's not working, but oh well. A variable. A variable is a symbol, usually a letter, that represents the value of a quantity. That's simple enough, right? The very common variable that we use is x. So that is why we don't use x for multiplication anymore. X is a variable, or y, or w, or p, or t. A variable can be any letter or any symbol that represents a number. Okay. A numerical expression. A numerical expression is a mathematical phrase or a mathematical sentence involving numbers and operation signs, but no variables. So for example, 8 plus 5 plus 12 divided by 3. That is a numerical expression. 18 plus 42, that's a numerical expression. You work and you make $12 an hour and you work 20 hours this week and you want to calculate how much you made, you're going to multiply $12 an hour times 20 hours. You're going to get 240. That whole thing was a numerical expression. So it's mathematical sentence or phrase involving numbers, operation symbols, but no variables. Remember that operation symbols, gentlemen, we're talking about plus sign, multiplication, division, or subtraction. Those are operation symbols. Division. Remember that division can be represented with a fraction bar. I can say, of course, 12 divided by 3. That's very elementary. But I can also say 12 over 3. Isn't that a fraction, Morrow? Yes, it is a fraction. But what is a fraction? A part of a whole. And a fraction can be turned into a decimal, right, by dividing. So that fraction bar also indicates division. Does that make sense, brothers? Thank you, gentlemen. Okay, and now an algebraic expression, good news, it's very similar to a numerical expression. An algebraic expression is a numerical expression which includes one or more variables. So if I throw in a variable into a numerical expression, now it is called an algebraic expression. So if I have x plus 4, that's it. That's an algebraic expression. 22 divided by 3x, that's it. It's an algebraic expression. 18 plus 2y, that's it. It's an algebraic expression. Notice I do not mention an equal sign here. When I add an equal sign, that becomes an equation, okay? These are expressions, and an expression does not have an equal sign. Okay? Next, term. This is probably the most important vocab of the day because we're going to be working with terms for the rest of the year. Bless you. A term is an expression that is a number, a variable, or the product of a number and one or more variables. So a term is 4, that's a number. A variable, z, or the product of numbers and or variables. 8 times 4, that's going to give you 32, that's a term. But 3 times x squared y cubed w, those are all being multiplied, so that's a term. You may ask, what separates terms then, Mauro? Plus and minus signs. Okay, we're going to get into this more detail later, but if I go x plus 3, how many terms are here? 2. The x and the 3. Plus and minus signs separate terms. So a term is any number, variable, or product of numbers and variables. Terms are separated by plus or minus signs. A coefficient, gentlemen, is the number being multiplied to the variable, or in other words, the number in front of the variable. It is the numerical factor of a term. It is the number being multiplied to the variable, the number in front of the variable. So if I gave you 6x, 6 is my coefficient. If I gave you negative 4zw, negative 4 is my coefficient. Yes, sir. A term, okay. And a term is any number, like 4, any variable, like z, any product of numbers, like 8 times 4, or any product of numbers and variables, like 3 times x squared times y cubed times w. Those are all being multiplied. No, I did not say it could be anything. If you put in addition and subtraction, now you're talking about you have several different terms. So if I have 8 plus 3y minus 2w, how many terms do I have? 8 is a term because it's a number. 3y is a term, yes, because it's a product of numbers and variables. And negative 2w is a term because it's a product of numbers and variables. Excellent question. Thank you, my man. Yes, sir. Yes, sir. Yes, coefficients are numbers in front. Sometimes people write things like this. That is wrong. That's not the proper way to write math. An exponent is not a coefficient because an exponent is not in front of the number. An exponent is up here. We're going to talk about exponents. Thank you so much for caring, sir. Thank you, thank you, thank you. Okay. Now a constant. A constant term, guys, is just a number. It's just a number. Any number by itself, no variable. It's just a term by itself as a number. It's just one plain number by itself. No variables. Okay. Now, like terms. Like terms are kind of like, I like to teach you like if you're going to a grocery store. If you go to the grocery store and you get 5 apples, but then you keep going down the aisle and then you buy 5 bananas. Do you have 10 apples? Do you have 10 bananas? Why? Because you can't add apples and bananas. They're different things, right? Well, if you get that, guys, guess what? You got like terms. Like terms, literally, are terms that have the same variable raised to the same power, y'all. So an x and an x, those can be added. Okay, only like terms can be added. Only. Any terms can be multiplied. I can multiply 3x and 2y. That's going to be 6xy. But I cannot add 2x plus 3y. You can only add like terms. And like terms are terms that have the same exact variable raised to the same exact power. So 2x squared plus 3x squared is 5x squared. Yes. What about 2x squared plus 3y squared? You can't add those because they're not like terms. Beautiful, son. Yes, sir. You cannot add 2x squared or 2x cubed because they have the same variable x, my brother, but not the same exponents. Great example. Thank you. Okay. Okay, so now let's go ahead and practice. For our first example, gentlemen, I want to identify A, the terms, B, the coefficients, C, the constants, and D, the like terms. That's what I want to do. So let's see what we got. Okay, A, the terms. What do you think the terms are? Remember, hint, hint, terms are separated by plus or minus signs. Yes, sir. Okay, so what are the terms? Let's list them. Negative 4ax, yes, sir. Comma 7x. Negative 6ax is a term. And positive 4. Very good. The sign always goes with the term. Excellent, brother. Okay, how about B? B is the coefficients. What would the coefficients be here, gentlemen? Negative 4, 7, negative 6. No, 4 is not a coefficient, my brother. However, for C, I want the constants. What are the constants here? What's the only constant here, guys? 4 is the number by itself. And then, yes, sir. Because they're coefficients. And a coefficient is the number being multiplied to the variable. The number in front of the variable. Isn't this negative 4 being multiplied to ax? No, 7 has an x, though. It's a coefficient. I don't know what you mean that works. That is the pure definition of it. The definition of a coefficient, my brother, thank you for your honesty, is the number being multiplied to any variable. So in this case, isn't negative 4 being multiplied to the variables ax? So that's a coefficient. Isn't 7 being multiplied to the variable x? So that's a coefficient. Isn't negative 6 being multiplied to ax? That's a coefficient. Thank you, my brother. I think what you're talking about is you thought I was saying they were like terms. They're not. For D, D is the like terms. What are the like terms here? Negative 4ax and negative 6ax. Those guys I will be able to add, and that's what we're going to be doing a little bit later today. Okay. How about number 2? And actually, let me give us a little bit more space. Okay. All right, so for number 2, gentlemen, what is my A? What are the terms here? 3x squared, 5x squared, 9y cubed z, 2yz, negative 4y cubed z. Beautiful. What are my coefficients, gentlemen? 3, 5, 9, 2, not 4, negative 4. Good. What are my constants? None. Beautiful. What are my like terms? 3x squared and 5x squared. Beautiful. And 9y cubed z with negative 4y cubed z. Beautiful, gentlemen. Very proud of you. Very proud of you. Very proud of you. How about for number 3, gentlemen? What are my terms? Go ahead. Beautiful. 8x. Negative 3y. No. What's a negative times a negative? That gets everybody always. Good job. Good mistake. That's a 6x. Great. And 5. Very good, brothers. What are my coefficients, gentlemen? 8. Yeah. Yeah. What are my constants, if any? Yeah. And what are my like terms? 8x and 6x. And that's it. Awesome. Last but not least, what are my terms, please, gentlemen, for number 4? 2x squared, negative 8y cubed, negative 6x squared. What are my coefficients? 2, negative 8, and negative 6. What are my constants? Yeah, none. And what are my like terms? 2x squared and negative 6x squared. Does everyone see what terms, like terms, coefficients, and constants are now? Does that make sense, my brothers? Thank you, gentlemen. Okay, now exponents. I know you guys have seen exponents before, but hopefully I'm going to open your world to what exponents really mean. And first of all, I have this 2, and then I have a little 3 up here. Well, this 2 is called the base. Oh my gosh. Sorry, guys. I don't know why this is not working today. And this is called the exponent. Okay? The base is the number, the big number, and that little power, the little number on the top, that's called the exponent. And what the exponent tells the reader to do is to multiply the base that many times. So when I have 2 to the 3rd power, okay, this is really telling the reader, hey, I have to multiply 2 times itself 3 times. And what is the answer? 2 times 2 is 4 times 2 is 8. So it's very important for you guys to realize that when we're dealing with exponents, the exponent tells the reader how many times to multiply the base times itself. It's very, very important, gentlemen. Very important. Reading exponents is very important as well, believe it or not. Just as important as vocabulary is being able to read math. And when you're reading exponents, always read it as follows. It's the base to the blank power. So 5 to the 3rd power, 5 to the 9th power, 12 to the 6th power, 8 to the negative 12th power. It's always the base to the blank power, whatever power is there. Okay? So for example, 3 with an exponent of 4 would be read as, sorry guys, this is really annoying me. 3 to the 4th power. Yes, thank you. Now, the power of 2 and the power of 3 have a special name. I'm sure you guys have heard it before. Do you guys remember what is a power of 2? Squared. Very good, gentlemen. And what is a power of 3? Cubed. Excellent, gentlemen. You guys rule. Thank you. So 4, bless you, to a power of 2 would be read as 4 squared. Yes, sir. Does that make sense, gentlemen? 8 with a to the 3rd power should be really read as 8 cubed. Okay? Now we're going to get much deeper into exponents as the year continues, but this is just the beginning. You with me so far, gentlemen? Thank you, gentlemen. Okay, now I want you to expand each expression as a product of factors. So in this case, I need to explain something very, very clearly. Okay, very clearly. The exponent affects the variable or the number directly to its left, or everything inside of parentheses. Let me explain. This 5th power only affects the x, y'all, not the 8. So this is really 8 times x times x times x times x times x. I want you to understand what this means. We can't work with it unless we know what it means. Okay? Now for b, my brothers, for b, we've got negative 2x to the 4th power. So this is inside of the parentheses, so everything gets affected here. Everything. So what's happening here is it's literally a negative 2x times a negative 2x times a negative 2x times a negative 2x, because negative 2x is being raised to the 4th power. I need you guys to really see that, and if you don't, you need to tell me so I can help you. Okay. C, y plus 2 cubed. People get confused with this. Don't. What's the base here? Y plus 2. So y plus 2 cubed would literally equal y plus 2 times y plus 2 times y plus 2. Bam. It's the base multiplied by itself as many times as the exponent tells you. Okay? How about D, 5 to the 7th power? Hold on, give me 1 second. So, okay, so I got 5 to the 7th power. So my base here is, and my exponent is, so this is telling the reader, hey, reader, Multiply 5 times itself 7 times. So it's 5 times 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5, 6, and times one more 5. Yeah, you got it now? I heard the magical, oh, that's exactly what I want. Understanding. Good job. Now, I've got 6x cubed. So that means that since the 6x is in parentheses, everything inside the parentheses is getting affected. Now, this 5 only affects the y, my brothers. So this is going to equal 6x times 6x times 6x times y times y times y times y times y. You're never going to expand this in real life, guys. I just want you to know. You're never going to expand it on a quiz either or a test. Why are we doing it then, Moro? So you can understand what the exponents mean, and you can understand who is affected by the exponent, okay? Who is affected by the exponent? Okay. Let me see something. We still got a few pages. Okay. You know what? We're going to call it right here. I wanted to do more, but that's okay. We didn't have time. I'd rather do it properly than rush, okay? So this is going to be part 1 as I'll post it. We'll finish part 2 on Monday. Thank you so much. I hope you learned a lot and have a great day.